Our event finally has to be written down, but written in what? Every health record is really two layers stacked on top of each other, and confusing them is the most common beginner mistake in this field. The first layer is vocabulary, the codes, the actual clinical facts. This diagnosis, this lab, this drug, those are the words. The second layer is syntax, the container, the format that packages those words and ships them between systems. That's the grammar. Words and grammar, vocabulary and syntax. Keep those two separate in your head, and this entire subject gets dramatically simpler. Start with the words. There is no single medical dictionary. There are several, and each one is built to name exactly one kind of thing. ICD-10 names diagnoses. It's the billing and statistics language. What's wrong with the patient? In codes the payer will accept. SNOMED CT names clinical concepts, and it's the richest of them all, granular enough to capture what a clinician actually means. CPT and HCPCS name procedures and services, what was done and billed. LOINC names labs and observations, what was measured. And drugs get two languages. RxNorm names the medication as a concept, while NDC names the exact package on the shelf. 6 vocabularies and notice, none of them overlap cleanly. Each one owns its own slice of reality. Now the container. The very same clinical fact can be shipped in wildly different envelopes. HL7 version 2 is the old workhorse, pipe-delimited messages that still move most hospital data today. Ugly, but everywhere. C-CDA wraps the same facts in a structured clinical document, the big XML summary your patient portal exports. FHIR is the modern one. Each fact is a resource you fetch over a web API in clean JSON. It's the reason modern health apps can finally talk to each other. Same A1C result, 3 envelopes. The vocabulary inside never changed, only the grammar around it did. Here is the beat that makes it click. One event, our diabetes visit, written in every system at once. To the biller, it's an ICD-10 diagnosis, E11.9. To the clinician system, it's a SNOMED concept, 4405-4006. To the visit and the test, it's CPT 99213 for the office visit, 83036 for the A1C. To the lab result, it's LOINC 4548-4, reading 7.4%. To the pharmacy, the metformin is RxNorm 6809. Same reality, 5 grammars. Every one of these describes the exact same afternoon, and not a single one of them contains the others. So when a founder says, "We'll just join the datasets," here is why that sentence should scare you. Dataset A calls our patient's diabetes E11.9. Dataset B calls the same disease 4405-4006. Same disease, same person, 2 completely different strings. Join them on the code, and the computer sees 2 things that do not match, and it silently drops your patient on the floor. The fix is a terminology map, a crosswalk that knows E11.9 and 4405-4006 are the same disease, and that NDC packages roll up into RxNorm drugs. With the map, the join works. Without it, you don't have integrated data. You have 2 spreadsheets that happen to be sitting near each other. Terminology mapping is invisible, unglamorous, and the entire difference between a real dataset and a demo. So now look at any raw health record and you can place it. Is this a vocabulary or a syntax? Which one and what does it name? You can tell an ICD code from a SNOMED code, HL7 from FHIR, and you know that joining them takes a map, not a hope. The 5 origins from last chapter can finally describe one event in a shared language. But there is a deeper problem hiding underneath all of it. Every one of these records quietly assumes it already knows who the patient is. Across datasets, that turns out to be the single hardest question in the field. Chapter 4. Identity and Linkage.